Welcome to Barkland Labs. Today's lab is the Mini Submarine lab, and it's also me teaching you about how we use these YouTube PreLab videos. One of the first things I always talk about in the YouTube PreLab videos is safety. Like I said in class, it's my #1 priority for you guys is that we stay safe, and then we can learn and have some fun too. So there's not a lot of safety concerns here. Don't eat the effordent. Don't eat pennies. Hopefully that goes without saying. Probably one of the real main concerns for safety actually is just we're dealing with a lot of water. It's if you spill water on the floor, it's easy to slip on the floor and fall, hit your head on something. So be careful not to spill, and if you do, let's make sure we get a rag to clean that up. So that's safety. Number 2 is I want to talk about the procedure. This is actually a little bit of an unusual experiment in that I'm not really giving you the procedure. You have to figure it out. And then you are going to write that procedure in a way that other people can replicate your results. That's what the scientific method is about, is being able to test out somebody else's procedure and see if you get the same results that they get. So instead what I'm going to do is I'm going to give you some parameters. I'm going to tell you what I want you to do. You've got a film canister. I know you don't know what these are anymore. We don't use these. We use digital cameras. But this used to hold something called film. Back when Mr. Barkland was in 8th grade, we had cameras that you would take pictures, and then there'd be a little roll of film inside. You'd take it out, and you'd take it to Walgreens, and they would develop your pictures for you. So these are antiques at this point. And what I did, notice I drilled a hole on the inside of the lid of the film canister. This is your submarine. You also have at your disposal pennies. You've got water, and you've got something called an effordent tablet. I'll get to that in a second. Your goal is to get the submarine to, when you drop it into this graduated cylinder, sink to the bottom, and it should, where the cap should be on, sink to the bottom, and it should stay there for about 15 seconds, and then it should rise back up again. That's the challenge. That's the goal. I'm not telling you exactly how to do that. I've told you what you've got. You've got the pennies, you've got the tablets, you've got water. You can use all of those, and I want to see if you can figure out how to make that happen. There are a couple of tricks to it that I'm not telling you. I want to see if you can figure out. That's part of science too, is some guess and check, some trial and error, seeing if you can make progress and get things to work better. So the effordent tablet. These are actually, you'll notice, antibacterial denture cleaners. I don't use denture cleaners, although after I bought these on Amazon, I've been getting lots of weird ad suggestions ever since. But these are tablets that are effervescent. That's why they get that word effordent. Effervescent just means that it gives off gas. So when I drop it here into the beaker, you'll notice I'll put it up to the camera. You can see all kinds of bubbles being given off by that. There's actually a chemical reaction that's happening right now. It is citric acid in a solid form, dissolving into the liquid. And that acid reacts with sodium bicarbonate, a base, and the product of that reaction is giving off carbon dioxide, a gas. So all those bubbles you see are carbon dioxide being given off. So your challenge is, how could you use the ability to produce a gas to make your mini submarine float after 15 seconds. Once again, I'm not going to give you too many hints about how you can do it. That's kind of the fun and the puzzle, is trying to figure that out. But there is our effervescent reaction. Okay. Other things that I oftentimes talk about so that was kind of a conceptual thing I just taught you. That's a third thing: safety, procedure, concepts. And fourth that I talk about a lot of times in videos is control variables. There aren't any control variables that I'm really talking about in this experiment. They are things that you want to keep constant so that it doesn't affect the outcome of your experiment. That's going to be the subject of our next lab that we'll start maybe next week or early the week after that. So that is it. Hey, I've got a couple of quick addendums to that last video. The first is just to talk about how you're going to start this lab. The first thing you want to do is try and find how you can make the film canister kind of neutrally buoyant. That means you want to get it to the point where it sinks down really slow in the graduated cylinder, and maybe it doesn't sink down super fast or isn't floating like this right now, because that means you're going to get pretty close to the point where it will be able to stay down there and rise back up. That's going to be kind of your first thing, and I actually don't want you using the Effordent tablets in that first part of the lab where you're just testing out combinations to see how we can make it sink, and then or just to kind of be that neutrally buoyant or close to neutrally buoyant. That's part number one. Part number two is you might be asking yourself, Mr. Barkland, I've got big old hands like you do. Can't get in there and get the film canister. Well, this is what you can do to conserve water. You're not going to need to get new water every single time and not spill water everywhere. We've got these lovely cans from the dining area place, and then you just pour that out in here, collect that, and then nice little funnel here, and put that back here, and go kind of slow so you don't spill everywhere. You can pour that water back into here. One thing to note with this is you don't need to fill the water way up here to the top. It'll be just fine if you've got just enough where it, maybe halfway full, a little over a third of the way full. That's plenty of water to fill that up and get that working for you.